In this video, we are going to solve some electrostatic problems where we deal with the Coulomb force in any medium of dielectric constant K. By the way, note that dielectric constant K that we are talking about is a relative dielectric constant or relative permittivity. You know that permittivity of free space is epsilon 0 with some value 8.85 into 10 to the power minus 12 with the units. Okay, this is for vacuum or air. This is for vacuum, or you can say air, right? It is nearly same for vacuum and air. But now for another object, let's say any object, glass or liquid, any sort of liquid like oils and all, epsilon 0 will not be the constant of permittivity, it will be epsilon, right? So epsilon is for any other medium, right? Now if I take the ratio of this epsilon by epsilon 0, that ratio is equal to K. This ratio is called relative permittivity, right? Relative permittivity for vacuum or air is obviously 1 because epsilon 0 by epsilon 0 is 1. So we are taking the air or vacuum as a reference, and compared to that we are seeing other mediums permittivity, right? So that is relative permittivity. Now whenever I talk about K as a dielectric constant of a medium, that means it is a relative permittivity. Some people use this symbol as well, epsilon r, right? Okay. Now you should know this, and another thing that you should know to solve the problems is that Archimedes principle. You know that if I have a fluid in a container like this, correct? If I have a fluid in a container like this, and if I have placed an object, right, in this particular fluid, now what this object will do, this object may float or may not float, right? Let's say it is half floating, it is half of it is submerged, or more than that is submerged, I don't know. Let's say the volume displaced is Vd, volume of the water displaced by this object is Vd. Some amount is under the water surface and some amount is above the water surface, right? So according to the Archimedes principle, it states that the upthrust, that is the upward force, of course when you put any object, right, in a fluid, then it will feel less heavier. Why? Because there is a upthrust by the fluid exerted upwards on that particular object. You will feel lighter if you go inside a water, right? Okay, now this is the volume displaced. Archimedes principle states that the upthrust is nothing but the weight of the water displaced. What is the weight of the water displaced? The water has the density rho. Volume displaced is Vd. So of course the mass of the mass of the water which is displaced is rho into Vd, because rho is the density of the water, Vd is the volume displaced. This can be anything. It can be water, honey, liquid, oil, any oil or whatever thing, right? So rho Vd, now multiply it with G. This will give you the weight of the water displaced. So upward force is rho Vd G. Upward force is rho Vd into G. Correct? Right. So this thing you should know. If the body is totally submerged, this will become rho Vg, where V is the total volume of that body. V is the total volume, because now the volume displaced is nothing but the volume of that object itself, right? Okay. So now we are going to solve the questions. Let's look at the first question. Let me erase it first. Correct. Let me erase this thing. Let me erase it fast. Yeah. Okay. So let's see what the question states. Two identical charge pairs are suspended by strings of equal lengths. Okay. Making an angle 30 degree at the pivot, right? Okay, with each other when suspended in a liquid of density 0.8 gram per centimeter cube. Centimeter cube, and the angle remains the same. The density of the material is 0.6 gram per centimeter. Okay. Yeah. Now find out the dielectric constant of the liquid. Okay, let's see at this question. There are two spheres which are charged, of course, and they are repelling each other because of the electrostatic force, and these two strings are making an angle 30 degree at the center, right? and the rho is the density of the liquid in which this whole apparatus is going to be placed. Sigma is the density of these two spheres. Okay, yeah. What we have to do is we have to find out the value of K. This is AIEEE question asked in 2010, right? Let's look at this question. Okay, so now they are saying after we keep this apparatus in another medium, the angle doesn't change. The angle doesn't change. That means it remains the same. Okay, so what may have happened? See, okay, see, if here I will show you the free body diagram. There is a tension like this. Here mg force is like this. And of course, the electrostatic force is there in this direction. Correct? And this is the angle. Okay, so if I bisect this angle is theta, then this angle is also theta by alternate angles theorem. Okay, now see here, this T has one component in the vertical direction, which is T cos theta, and this has a horizontal component T sin theta. You know this. Now see, T cos theta is balancing mg, F is balancing T sin theta, right? Okay, by some way or the other, what happens that this force, maybe this charge got leakaged, okay, these charges went out, some of the charges. So what happens, the electrostatic force decreases. So if electrostatic force decreases, this will also decrease, right? So now what will happen is that this, if you write this angle over here, T sin theta is balanced by F, right? And T cos theta is balanced by mg. T cos theta is balanced by mg, right? So tan theta is equal to F by mg, right? Okay. Now, if some way or the other my force F reduces, what will happen? If the force reduces, this theta will also reduce because it is tan theta, right? So this tan theta, this angle will also reduce and they will be coming closer to each other. If some way or the other mg got reduced, if mg got reduced, then what will happen? These angles will increase. You can see mg reduced means this ratio will increase. Tan theta will of course increase. So theta will increase. So they are going to move in this direction, right? Okay. Yes. So that is going to happen. But now in this case, they are saying these angles are not changing. These angles are not changing. That means it is same. Okay. So I got tan theta is equal to F by mg. This is in vacuum. Now we are placing it in some another medium. Let's place it in some another medium. Now the angle is not changing, right? So let's keep the angle same. This is angle theta. The tension is T. The tension will not be same, by the way, it is T dash. Why? Because your force will be different. Now the new force will be F dash is equal to 1 upon 4 pi epsilon Q1 Q2 by R square, right? This is the new force. But what is epsilon? Epsilon can be written as epsilon naught into K. So F dash can be written as the original force, which was 1 upon 4 pi epsilon naught Q1 Q2 by R square, and this is K. This was the original force, right, which is F. So this can be written as F by K. So F dash is your F by K force, right? So instead of that, now F by K force will be applied in this direction. F by K force will be applied. Tension is T dash. The downward force is mg again, right? Okay. Now the thing is here, they are putting it in the density rho. They are submerging it. So there will be an upthrust force. The upthrust force will be like this in this direction. What will that upthrust force will be? Rho times volume of this ball. Rho times volume of this ball into g, right? But volume is not known, but they have given density of that particular sphere, that is sigma. So sigma is nothing but mass upon volume of that sphere, right? So instead of V, I can write m by sigma. So this is rho m by sigma into g. This is the upthrust. Now this will be net gravitational force will be mg minus rho mg by sigma. I will tell you why I have written like this. I could have shown this upward as well, but I will tell you why I have written like this. Okay, so T dash, this is angle theta. So this is also angle theta. Why? This angle does not change. It is given in the question, by the way, right? So now if I take the component of this will be T cos theta upwards, and this will be T sine theta towards right. Okay, so T dash sine theta is equal to F by K, and T dash cos theta is equal to mg. Mg can be taken out, so mg into 1 minus rho by sigma, right? Okay, now if I take the ratios of these, you will get tan theta is equal to F by kmg into 1 minus rho by sigma. This is what tan theta is. Now these two angles are equal, so I can equate these two things, right? So let me check if everything is visible. Yes, it's visible. Okay, now what we will do, we will equate these two. You can do yourself, sorry, this one and this one. You can try this yourself. If you can't, I will do. Okay, see this. Tan theta is F by mg. This is F by mg is equal to F by kmg into 1 minus rho by sigma. So F gets cancelled, mg gets cancelled. We will get k into 1 minus rho by sigma as 1, right? Rho is 0.8. Okay, this is 0.6. Okay, it is 1.6. Sigma is 1.6. Okay, sigma is 1.6, so this is 0.8 divided by 1.6. 1 minus is equal to 1. This is k. So of course this is 0.8 into 2 is 1.6, so this is 1 minus 1 by 2 is equal to 1. 1 minus 1 by 2 is 1 by 2, so this is k by 2 is equal to 1, and k is equal to 2. So the k value is becoming 2. The answer is that 2. Okay, let's look at the next question, which is similar like this. Here we have been given the two spheres, charge spheres, right? This was asked in JEE 2024 mains. Okay, so they are being given two identically charged spheres. The angle this string makes with each other is 37 degree. Right now, this whole apparatus is these are two identical spheres, by the way. This whole apparatus is made to go in a liquid of density rho, which is equal to 0.7 gram per centimeter cube, and the sigma, that is the density of this spheres, is 1.4 gram per centimeter cube, right? Okay, now remember that whenever this sigma is greater than rho, that means this particular object will sink. Okay, it is not going to float. They will never give you a question in which case they will have sigma to be lesser than this. Otherwise it will not go down, right? It will not float. It will not sink. Now what happens here? The tension is T. Again the same story. This is angle theta. This is angle theta. So I think you should try this question yourself. Okay, so this is angle theta, so this is theta. So there will be a force of electrostatics, and mg will be the downward force. This is before putting it into the medium. So this is T cos theta and this is T sin theta. So before putting it in a medium, I am writing this. So T cos theta is mg. T cos theta is equal to mg, and T sin theta is equal to f. If I take the ratio of this, tan theta is equal to f by mg. Okay, now good. Now what will happen? We will put it in some medium. Now I will make changes here itself. Now the tension will become T dash. They have given the angle does not change when they put it in a new medium. So that means it will remain theta. So this is T dash cos theta, this is T dash sin theta. This is not mg now, right? There will be a upthrust. What is that upthrust? Density of water, volume of that sphere into g. But you know sigma is equal to m by v. So instead of v, I can write m by sigma. So I can write m by sigma here. So this is mg minus rho m by sigma into g. So I can take mg common here, and it will be mg into 1 minus rho by sigma, right? Okay, so this is your new force. This is T dash cos theta basically. This is balancing this. Now this is new force F dash. which will balance out t dash sine theta. So t dash sine theta is nothing but f by k, right? Okay, so t dash sine theta by t dash cos theta will be tan theta, which is equal to, what is tan theta? F by k divided by mg, f by k divided by mg into 1 minus rho by sigma. Now these two are equal, so f by mg is equal to f by k mg into 1 minus rho by sigma. So f and f gets cancelled, mg gets cancelled, so you will get k into 1 minus rho by sigma is equal to 1. But rho is 0.7 and sigma is 1.4. If I take the ratio, it will be 1 by 2. Again the same result will come, k into 1 minus 1 by 2 is equal to 1, right? You are getting the same result because this ratio in the previous question was also same, it was 0.8, 1.6. Okay, so this k will become 2. Again the same answer, right? Okay, so this is all for this video. Thank you.